Hello everyone, and thank you for joining today. Today, I will be presenting on harnessing AI for autonomous threat defense in multi-cloud security. My name is Pradeep Kurra. I'm a principal architect at Trace3. Today, we'll explore how artificial intelligence is transforming security in multi-cloud environments, helping us defend against increasingly sophisticated cyber threats. Let's begin by acknowledging the reality we are facing today in cybersecurity. The threats aren't what they used to be. Legacy security frameworks, things like basic firewalls, VPNs, and intrusion detection systems, these were designed for a world where threats were simpler, slower, and frankly easier to spot. Today's threats are incredibly dynamic. We are seeing graphic malware that changes its code every time it executes. We are facing advanced persistent threats, attackers that sit quietly inside networks for months, learning, adapting, evading detection. And let's be clear, these are not the work of random hackers anymore. It's highly organized, often state sponsored, and increasingly automated. Machine learning is now used by attackers themselves to develop smarter, faster exploits. One of the biggest problems, isn't it? The gap between when an exploit is created and when it's launched is shrinking. Organizations barely have time to patch these vulnerabilities before attackers strike. The old models of detect then respond are too slow. We need a fundamentally new approach, and that's where AI begins to shine. And now let's talk about the AI security advantage. AI brings three transformative capabilities to cybersecurity, and it's important to understand them individually. For the first, let's talk about real time analysis. We all know AI can process petabytes of security data, such as logs, network traffic, user behaviors, within milliseconds. It's like giving your security operations team a superhuman vision. Patterns that would take a human analyst days to recognize or surfaced instantly. Second is autonomous response. Historically, once an alert was raised, humans had to analyze, validate, escalate, and finally act that takes hours or longer. In the meantime, the attacker is moving, stealing, and damaging the enterprise. Now, AI flips this. Systems now detect threats and immediately act by isolating infected machines, shutting down dangerous processes, often without needing a human to approve it first. Third, and perhaps most exciting, is adaptive defense. AI based systems are self learning. Every attack they see, every anomaly they process, makes them smarter. They evolve alongside attackers. Traditional signature based defenses are static. AI based defenses are alive and growing stronger every day. When we talk about measurable improvements using AI, we are talking about operational realities, not theoretical promises. Think about false positives. In many organizations, security teams are drowning in alerts. 90% of those alerts, they're just noise. By reducing false positives by 30%, AI doesn't just make teams more efficient, it helps them focus on the right threats faster with less burnout. Response times are cut by 50%, means incident that used to take 6 hours to mitigate now takes under 3 minutes. In cybersecurity, speed is everything. Every second an attacker remains inside your network increases damage exponentially. And a 40% faster incident resolution rate reduces not just the duration of attacks, but also their downstream costs like regulatory fines, lost customer trust, and recovery efforts. These numbers translate into real business value, not just better security, but stronger bottom lines. Now let's talk about AI powered behavioral analytics. Traditional security often relies on static rules. For example, if X happens or Y happens, block it. The problem is attacker knows these rules and they find ways around them. But now let's see it with the AI, it takes a different approach. AI watches it and learns from it. It knows what normal looks like, not based on rigid definitions, but based on continuous observation. For instance, or for example, if a user always logs in from Austin between 9 a.m. to 5 p.m., and suddenly there's a login from Singapore at midnight, that's flagged immediately. Or, for instance, if a database starts sending unusually large amounts of sensitive data outside normal business hours, AI detects that. And crucially, it doesn't just flag anomalies, it takes action. It takes action by automatically locking those suspicious accounts or isolating those suspicious devices. AI prevents minor anomalies from becoming major incidents. Now let's talk about zero trust implementation. I believe this has become a buzzword, but it's also a fundamental principle. It's like never trust, always verify. That's zero trust implementation, right? So we can no longer assume that because a device is inside our network, it is safe. We must verify everything, like every user, every device, every access request. Least privilege means thinking critically about access. Does this really does this user really need database admin privileges or can they just read reports? And assuming breaches means building layered defenses like microsegmentation. Microsegmentation is nothing but dividing the networks in enterprise into smaller zones, which limits the blast radius if an attacker breaks through. Now, with AI, it enhances zero trust strategies by monitoring trust continuously, not just at the moment of login, but during the entire session. Let's talk about AI integration with security platforms. AI enhances existing security platforms within multi cloud. Think about a typical SIM platform. SIM means security information and event management. Traditionally, what it does is it aggregates logs, normalizes data, and triggers alerts based on rule sets. But when you add AI, something powerful happens. AI can correlate security events across systems automatically. For example, it might see a strange authentication attempt in Azure Active Directory, which correlates with abnormal API calls that's happening in AWS Cloud and tie that to a suspicious download that happens in a GitHub repo. Suddenly, what looked like isolated events now tell the story of a coordinated attack. Similarly, in SOAR platforms, which is security orchestration, automation, and response platforms, AI helps automate this instance of handling these workflows. Now, imagine this: a phishing email is detected. AI automatically quarantines the email, locks affected user account, flags similar emails, and notify security analysts, all within seconds. Time is the key. And this all comes with no manual ticket triage, no waiting hours for investigation. This is fast, orchestrated with intelligent action. And finally, AI enriches alerts with contextual intelligence. Instead of just saying anomaly detected, the alert might include more details. For example, this credential theft attempt matches known tactics, techniques, and procedures of the advanced threat groups, for example, like APT29, and qualifies them as medium severity, or it would even take immediate action as recommended. This kind of context reduces guesswork for analysts and accelerates time to action. Now, let's talk about cross platforms cloud security. As organizations expand across AWS, Azure, GCP, in multi cloud environments, and even in hybrid environments, the complexity of managing security grows exponentially. There is no longer a single perimeter to defend. Your applications, data, APIs, and users are scattered across dozens of services and providers. Thankfully, these major cloud platforms have begun integrating AI into their security ecosystems. In AWS, services like Guardian AI continuously scan CloudTrail logs for unusual API activity. Imagine detecting an administrative API call happening at 2 a.m. from a country where you have no employees. In Azure, the Security Center uses machine learning to assess these vulnerabilities across compute, storage, and identity services, which predicts potential breach points before attackers can exploit them. In Google Cloud, Security Command Center applies AI too, and more importantly, to monitor containerized workloads. Given the rise of Kubernetes and microservices, protecting containers, which are dynamic and ephemeral, is critical. Now, ties all this together is that AI operates at cloud speed, analyzing millions of data points across platforms that would overwhelm human teams. When security is consistent, automated, and intelligent across clouds, it allows organizations to innovate confidently without sacrificing risk management. Let's bring this all to life with real world examples. Financial services are a high value target for attackers, as we all know, especially with the rise of fintech. But now, in fintech companies, banks can now deploy AI not just for fraud detection post transaction, but to prevent fraudulent authentication before it even succeeds. For instance, one of the major institutions implemented AI powered authentication anomaly detection, which prevented them over 4.3 million in losses in a single quarter. Think about the ripple effect. Not just money saved, but brand and trust are preserved. Similarly, in healthcare faces different but equally critical challenges. Patient data is among the most sensitive information in the world, protected by regulations like HIPAA. Hospitals now use AI to monitor network traffic for ransomware behavior patterns. The moment AI detects lateral movement or encryption behaviors associated with this ransomware, it isolates affected endpoints automatically, sometime before the ransomware fully executes. And in e-commerce, companies face relentless DDoS attacks, especially during peak season like holidays or major holiday sales. Using AI, they can analyze real-time traffic patterns to distinguish legitimate customers from bot-driven traffic. This allows them to mitigate attacks without disrupting real shoppers, maintaining revenue flow, and also, most importantly, the customer satisfaction. So, where are we headed? What does the future of cybersecurity look like when AI takes center stage? One major shift is towards predictive defense. Rather than just reacting to threats and that have already materialized, future AI systems will anticipate attack patterns based on early signals such as subtle network behaviors, metadata anomalies, or threat intelligence from around the globe. AI will model the most likely paths an attacker would take and proactively close the vulnerabilities before exploitation happens. We will also see more self-healing infrastructures. Imagine systems that, upon detecting compromise, automatically roll back to a secure snapshot or reconfigure themselves to eliminate infection vectors without even human intervention. Finally, with growing quantum computing maturity, traditional encryption algorithms will be increasingly vulnerable. AI will be critical in managing adaptive quantum resistant encryption strategies, evolving defenses in real time based on quantum threat levels. It's not just about detecting and responding anymore. It's about preemptively strengthening defenses faster than adversaries can adapt. To wrap up, let's review the key takeaways from today's session. First, AI is not optional anymore. The scale, speed, and sophistication of modern threats require defenses that are equally dynamic. Second, the results are measurable. Organizations that integrate AI see quantifiable improvements in reduced false positives, faster detection, faster response, and lower breach impact. Third, to start your journey strategically, begin with AI enhanced monitoring and instant detection. Build muscle there, then gradually move forward towards fully autonomous response capabilities. And finally, invest in your people. AI is not a magic box, it's a force multiplier for skilled security professionals. Develop teams that can work symbiotically with AI, analyzing complex situations, providing ethical oversight, and refining AI models with domain expertise. Together, AI and human intelligence are the future of cybersecurity. Thank you again for spending time with me today. I am excited about the future and I hope you are too. Thank you.